Good morning, friends. We'll see ASME-PCC 2, Article 202, External Weld Buildup to Repair Internal Thinning. Restoration of wall thickness. A weld buildup shall not be used for structural reinforcement when there is indications of any form of cracking. This should include an evaluation medium for potential reaction with the base material due to the heat from welding. Examples of process media that should properly flushed from the system prior to repair, including hydrogen, hydrogen cyanide, oxygen, alkaline caustic materials, butadiene, acetylenic compounds, H2S, chlorine, H2S2, I think so, H2S, chlorine, and acids. In some cases, cleaning procedures may be necessary to repair a pressure component. Operation on creep temperature range that are operated at or near to the creep temperature range should only be qualified through an engineer design approach described in section 3 of this article. Blocked in liquid filled components. Blocked in liquid filled components should not be repaired due to potential for pressure increase from thermal expansion. Chemistry. The nominal chemistry of the deposited weld metal shall match the base metal. Tensile strength. The tensile strength of the deposited weld metal shall be at least equal to or exceeds the tensile strength. Shall be a tensile strength of the base metal to which the weld buildup is applied. Weld buildup profile. Something like this. They build up this area because of corrosion. So how and why? Post-repair examination. The design of the buildup shall not hinder post-repair examinations and evaluations or any pre-service examinations. Extension beyond base metal. The weld shall extend at full thickness a minimum distance b in each direction beyond the affected base metal unless otherwise justified by fitness of service assessment. B equal to 3 by 4 of root over RT nominal. R is the outer radius of the component, or half D. P nominal is the nominal wall thickness of the component. So B is 3/4 of root over RT. So this is B, the extension beyond the edge taper. The edge of the weld buildup shall be tapered to existing pressure component surface at a maximum angle of 45 degrees. Shall be the thickness shall be sufficient to maintain the predicted life of the repair. All corners of the buildup shall have a radius r not less than buildup thickness. So it should be more than the build-up thickness or equal to. Corrosion allowance. Any corrosion allowance that are determined to the necessary shall be added to this dimension. The predicted maximum degradation of the build-up pressure component and the build-up over the design life of the restoration shall be analyzed. Spacing. In addition, the two or more build-ups shall not be spaced any closer than 3 by 4 r root over rt nominal between the two of each build-up. Thickness. The thickness of the completed build-up dimension W in the figure shall not exceed the nominal thickness of the pressure component. Build-up qualification requirement guidelines for pre-qualified design para number 202-3131, guidance 332, guidelines for proof bus test 2023133, pre-qualified design. Pre-qualified design and shall be exempt from the engineer design qualification or a proof test qualification if all the following conditions are met. All the requirements of para number 2023132 are met. D11 and 312 are met. The maximum design temperature doesn't exceed 340 degrees centigrade, 650 degrees Fahrenheit. The specific nominal thickness of the existing base metal is at least schedule 40 or standard wall, whichever is less. The maximum angle of the taper doesn't exceed 30 degree. Alpha in the figure 2031. The finished buildup is circular, oval, full circumferential or rectangular in shape. For each repair, the maximum dimensions, the length along the axis compensated by circular, oval or rectangular buildup doesn't exceed the lesser of 1/2 of the nominal outside diameter of pressure component or 200 mm, 8 inch. Rectangular buildups are aligned parallel with or perpendicular to the axis of the pressure component and corners are rounded with radii not less than the buildup thickness. Oval buildups shall have end radii not less than and axis of the buildup shall be aligned parallel with or perpendicular to the axis of the component. The minimum thickness of the buildup shall be sufficient to restore the nominal wall thickness of the pressure component. This can be accomplished by subtracting the remaining thickness from the nominal thickness of the component to obtain the required build-up thickness. The thickness of the build-up shall be relatively uniform except for the tapered edges. If the flexibility analysis was required by original construction code, the effect of weld build-up shall be reconciled with the original analysis or qualified in accordance with para 202.3.1.3.2. Engineer design. The effect of three-dimensional shrinkage, the effect of flexibility, stress concentration, and section properties. Stress concentration from the pressure component, internal surface configuration, the effect of differing thermal expansion coefficient between the base metal and the weld metal, the effect of differing thermal mass of the build-up repair, the potential for creep degradation for service temperature above 340 degrees centigrade or 650 degree Fahrenheit. General requirements. The base metal is same P number and group number as the mock-up base material tested. The specified minimum tensile strength of the item doesn't exceed that of the mock-up base material tested. The average thickness of the build-up areas is at least the thickness of the mock-up plug U. Figure 20231. The overlap on the full thickness of the base metal B is at least that of the mock-up. The transition angle of the outer edge of the overlay alpha is not greater than that of the mock-up. The build-up surface is similar to or smoother than that tested. The maximum axial dimension diameter ratio L by D is not less than that tested. The maximum circumferential dimension diameter ratio C by D is not more than tested. The nominal diameter is not less than 1/2 or more than 2 times the diameter of mock-up tested. The nominal thickness diameter ratio T by D is not less than 1/2 or more than 3 times T by D ratio tested. Simulation of thin area. To simulate the area of wall thinning in pressure testing, a rounded corner segment of the base material of the mock-up shall be removed to represent the maximum size ratio axial dimension of the L and circumferential dimension of C, the location of thinning or pitting to be compensated by the weld buildup. A plug of the same base metal and of uniform thickness U is not exceeding the smallest average thickness on which the buildup will be permanently applied shall be full penetration welded around the opening and flush with the outside surface of the pressure component. Alternatively, an equivalent volume of base metal may be removed from the inside surface of the mock-up by machining or grinding without the need of welding in a closure plug. Build-up thickness. Build-up section thickness deposit plus base metal represented by the dimension U and W For the thinnest area, mock-up shall be not greater than that 87.5% of the nominal wall thickness. This is intended to provide the conservative thickness of the qualification of the build-up design. Bust spacer. To qualify a repair design for general application on pressure components in the same orientation or the same location of fitting, bust spacer shall be not less than P equal to 2T S act by D. D is the outside diameter of pressure component. P is the minimum acceptable bust pressure. S act is the reported actual tensile strength MPa ESI. Then T is the minimum specified thickness, excluding manufacturing tolerance of base material tested. If flexibility analysis was required by the original construction code, the effect of build-up shall be reconciled with original analysis and qualified in accordance with 3.2. So burst testing pressure warning. Hydrostatic burst use testing has potential to cause loss of life. And damage to property. All tests shall be thoroughly evaluated for safety and control of debris from component failure. The pump station used to burst testing should be capable of exceeding the maximum calculated burst pressure. The pump should be capable of providing a minimum of 25% overpressure to allow for burst pressure variations from wall thickness tolerance. Weld reinforcement etc. In most cases, the actual burst pressure will exceed the calculated value by a small margin. Burst test fittings and gauges. Fittings and gauges. Hoses and gauges shall be rated for a working pressure equal to greater than the pump rating. Fitting attached to the pressure component mock-up should be threaded into the end wells of the mock-up and then seal welded to prevent leakage. Gauges shall be rated for working pressure at or above the pump pressure rating and shall be calibrated to a pressure standard traceable to the National Institute of Standard and Technology NIST or equivalent by reputed laboratory. The expected burst pressure of the component being tested shall fall within 1/4 to 2/3 of the gauge rating so as to be in the most accurate portion of the gauge measurement range. Preparation, inspection requirements, volumetric examination. Determine that cracking has not occurred prior to commencing the repair. Should be volumetrically checked. Surface examination, entire surface too, which build up and techniques to verify the surface quality prior to welding. Acceptance criteria shall be in accordance with the applicable construction code or post construction code. Surface preparation. Surface cleaning. Immediately prior to welding, the final weld surface should be thoroughly cleaned using a solvent such as acetone to remove any traces of oil and grease. This procedure will also help in removing traces of moisture. Surface contaminants may lead to porosity and other welding defects, which may adversely affect the welding quality. A clean surface will also assist in permitting more accurate non-destructive examination assessment of the pressure component wall degradation. Hello. Right. Okay. Yeah, but no, they already finished. No, they already finished the interview by telephonic. Yeah, telephonic by telephonic they completed the interview. Yeah, yesterday. Yeah, yeah. Only one. Oh, one person. Yeah, one person only. Yeah, yeah. How many? Yeah, yeah. Yeah. Ask them, ask them. Mm-hmm. Okay. Okay. Okay, okay. Let me see. Let me check. Okay, sir. Let me check. Well, वो टेलीफोनिक इंटरव्यू किया और कुछ नया नहीं आया। मैं फिर से चेक कर रहा हूँ। आप बोल रहे हैं लेकिन मैं चेक कर रहा हूँ। मेरे को भी भेजा था 7 बजे के बाद, लेकिन उसके बाद बोला उसका इंटरव्यू हो गया, तो इसलिए नहीं भेजा। आप पूछ सकते हैं उसको। एक आदमी बात किया, फिर दूसरा आदमी एचआर से बात किया, बट वो मीटिंग के लिए बोल रहा था, फिर बोला नहीं आपका इंटरव्यू खत्म हो गया, तो इसलिए ठीक। Wall thickness determination prior to initiation of welding. The remaining wall thickness shall be determined to ensure that the proper electrode size is used to prevent burn-through of the pressure component wall. Okay, sorry. Prior to initiation of welding, the remaining wall thickness shall be determined to ensure that the proper electrode size is used to prevent burn-through of the pressure component wall. It is necessary to minimize penetration during the first layer. Thus, smaller diameter electrodes should be used. The doubt about the accuracy of wall thickness, such as in the case of pitting, the smallest possible electrode should be selected. Pressure components with wall thickness less than the diameter of the electrode should be depressurized before welding. Consideration should be given to depressurizing the system before welding. Alternatively, appropriate in-service welding techniques as provided by API RP 2201 shall be used. Temper bead techniques as permitted in the applicable post-construction codes may be used on carbon steel or low alloy steel to avoid the need for high temperature heat treatment. Avoid use of temper bead methods where process or service conditions mandate use of heat treatment. H2S, HCN, HF. Bead overlap. The bead overlap of approximately 50% should be maintained to reduce the potential for burn through and to assist in obtaining proper bead placement. In some cases, wastage may have progressed to the point where there is risk of burning through the component when depositing the first layers. To prevent burn through in such a situation, the first bead should be deposited where the remaining thickness is greater. Then the subsequent beads should be overlapped to step across the thinner area. Initial welding pass provided an outer gauge for the welder. Improve the heat affected zone quality by eliminating the potential for final untempered weld pass on the base metal surface for carbon and low alloy steel material. After completion of perimeter weld pass, the first layer may be welded in accordance with the qualified weld procedure. An edge angle of 30 degrees is recommended and meet one of the provisions for pre-qualified design. The taper angle is important. It minimizes the stress intensifying effect of the buildup due to the changes in surface geometry. Edge taper angle. The maximum allowable edge taper angle is 45 degrees. There is edge angle minimum, maximum. Surface examination. The completed weld buildup shall be examined using liquid penetrant or magnetic particle method and shall satisfy the surface examination acceptance criteria. Volumetric examination. The full volume of the finished buildup, excluding the tapered edges but including the volume of base metal required for the design life of the buildup, shall be examined by either the ultrasonic or radiographic method. Volumetric examination in place of pressure testing. Volumetric non-destructive examination may be performed in place of pressure testing. When pressure testing is not practical, leak testing may be required to satisfy post-construction code requirements. Thank you, gentlemen. We'll stop here.